Today we'll be looking at subtraction in the x86 assembly language, and we'll just get straight into it. It's so easy, and let me illustrate to you. So I'll go ahead and create an empty file, an empty assembly file, and I'll be using nano. So nano, I will name it sub.s, so .asm or .s. Now go ahead and just declare the usual section text, which where we'll be writing our source code. Then go ahead and declare our starting point using the global start, and then we mark the label like that. Then let us move some registers and try doing subtraction. So I will move, and I will move, okay, I'll be using, let me be consistent, I'll be using this. So move to EAX the value 20, then I will move another value to the register EBX, maybe 10, like that. Then we'll just perform a subtraction. So sub, so there is this instruction, so sub EAX from EBX. So initially what this means, it will take EAX minus EBX, so which is in other terms is like, it will say like 20 minus 10, just like that. So, and let me write an interrupt here to return the control back to the operating system. I'll go ahead and save it and then try compiling it. So nasm-f elf32, so elf32 followed by the name of the file, so which is sub.s. Then we want to generate an object file, so sub.o. Then I'll go ahead and link it using the linker, so -m. So we're making an emulation of this format, so elf i386 followed by the name of our object file that we generated over there, which was sub.o. Then so now we want the executable, and I'll just name it the same, so sub. So if I ls, you can see that we have an executable, we have an object file and a source file. So I'll go ahead and open the debug and see what is happening behind the hood. So I'll be using gdb, so gdb followed by the name of the file, main, not main, so sub. Then go ahead and just type layout. We want the layout to be assembly. Then let us make a breaking point, so break, it will break at the start point, then run, like that. So we'll go ahead and step into each instruction, so like that. Then I will go ahead and step again, like that. Then I will step again until we reach to the interrupt over here, so step I. So to see the result will be stored at EAX. So I'll just go ahead and say info registers EAX. So you can see the subtraction has been generated successfully. So let's get back to our program and just try something different. So this, when you subtract, the result will be stored in the destination over here, which is EAX. So remember what we said about the mental model of how to think of these move values, what goes where. So you need to know that this is the destination, this is the source of the data. So the source of the data, or the data, will be stored or will be moved to the destination, which is this one over here. So let's try and maybe we can declare some variables over here. So as you can remember, we had another section for declaring our initialized data and constants, so we can go ahead and just declare it. So section, so to show you, like, you can use even the variables stored in the RAM. So section.data, because the variables here are stored in the RAM. So I'll go ahead, maybe I will define num1. Then I'll use dd meaning I want 4 bytes. So I want 4 bytes of memory, and I want to store the value 20. Then I will just declare num2. Again, I will store, I want a 4-byte memory, and maybe I will store the value 5. So what do you mean? So far we have seen that there is the db, which is 1 byte. We have dw, which is the double of the db, so this is the 2 bytes. And now we have seen dd, which is equals to, so dd is equals to 4 bytes. 4 bytes. So as you can remember, 8 bits make 1 byte. So let me illustrate to you. So if I declare something like 000 0 and 1 1 1, so this is a byte. This is a full byte. So 8 bits make, when compiled together, make 1 byte. So let's go ahead with the video. So we are declaring a variable called num1. We want 4 bytes of memory, and we want to store the value 20. We have declared another variable num2. We want 4 bytes, and we want to store the value 5 over here. So let's go ahead and go here. So we will move num1. So here, to get the value, you have to use the brackets like that, then num1. So what we are saying, we want to move the value of num1 into EAX, because if you leave it without the brackets, it will copy the memory address of the variable. Then again, we'll go here. So let me delete this one. So I can delete this one and just do some direct subtraction. So I can go ahead and just say sub. We want to subtract what? We want to subtract EAX from num2. Remember, EAX contains the value 20 because the value 20 was copied to EAX. Then we want to subtract what is in EAX, which is 20, from what is in num2, which is 5. So basically this is saying like we want to just do something like this. So we want, so let me put a comment. We are saying like 20 minus 10, because 20 was stored was moved from num1 to EAX. Then because EAX contains 20, we just subtract it direct from num2. And remember, don't forget these brackets to access the actual value. Now let's go ahead and store. So what if we want to store maybe let's declare another variable called result. Another, we want a 4 byte worth of memory. Then we'll store the value 0. Then over here, what we'll do, we'll move so our destination result. So because we want to store the value inside there, we want to move the result, which was from EAX, which is 10, which is 20 minus 10, which will give us 10, and just move it to this variable called result. Then remember, you have to use this in order to tell assembly to store the actual value, to work with the value instead of the memory addresses. Now, so let us compile it. Let us compile it and see what we'll get now. So we'll just go ahead and just run this command, then link it, then try using GDB layout. We want an ASM layout. Then we want to make a breakpoint as usual, so break at start. Yes, then let us run and start stepping into each instruction. So step I, so we are in the subtraction, then step I, then step I until we reach the interrupt. So here comes the question. In the previous section, we have seen that we can use info registers, register, maybe EAX, EBX, so on and so forth. But the result is not stored in a register. It is stored in an actual variable which is located inside the memory address, inside a variable which is stored in the RAM. So let us see. So let me quit. So I can, so my machine has, so let us quit the program. So let us see this. The result is stored in a variable which is located into the RAM or the actual memory. So we cannot use info register command inside the debugger. So what will we do? So let us, we have to include something that we call the symbol table, which in simple terms, simple table is, you can see it like a directory or like a key value pair, which maybe it stores the name of the variable, the size of the variable, and maybe the value. So it's like a table where the assembler or the compiler generates to locate each and every code that you have written and match it to a certain value, so that the assembler can understand. Because as we know, computers only understand zeros and ones. So through this symbol table, the compiler or the assembler is able to know what the name of the variable, the value, and the size. So let us include the symbol table because it's not included by default. So let us see how to include it. So as we compile, we'll start compiling from scratch. So I'll use nasm -f elf32 as usual. Then over here I will include the -g. This will include the symbol table. Then followed by the name of the source file, main.s or sub.s, then the output file, which would be sub.o. Then go ahead and link it. So also in the linking process we'll include it also, -m, so elf i386 -g followed by main.o, then -o. Now for our executable, so it's not main, sorry, it's sub. I'm used to main, so I will use sub, then -o. I will use maybe I'll name it, let me name it sub again. So there is a mistake over here, so let me correct it. So sub.o, so I think it is here, so sub.o, like that. Then I will go ahead and run the debugger. So sub and layout asm. We'll just maybe break at start, just run our program. So let's go ahead and step into each instruction. So step I until we reach the interrupt, step I. Now to see the actual variables inside memory, I will introduce a new line of command which will use the print followed by /d, meaning we want the decimal part of it. So if you want hexadecimal, you can use H or hex, I think so. But if you want to see decimal points, we use /d. Then we'll go ahead and name state the name of a variable that holds the results, which is the result, like that. So as we have run, you have seen we have encountered an error that says a result has unknown type, cast it to its declared type. So I'll go ahead, so to convert it or to cast the type, so I'll go ahead and use this brackets and give it a type, so it's an integer followed by the name of the variable, result. So as you can see, we got 15 because, let me go back. If we go back to our code, you can see num1 is 20, num2 is 5, if you subtract this will mean is 20 minus 5, which will be 15. So that's how you can do subtraction. So you can use external variables, or you can just use registers, but the subtraction operation is simple. So you can use this. So I've introduced this maybe to add some complexity to it, but for starters you don't need this section. You can just use row registers for moving data. So if I delete that, and maybe we say that we want to use just normal registers where we load values 50 here, then let me delete this one. So we can move something to EBX or any other register. Maybe I can move it to maybe 40. Then down here the takeaway point is that is here. So sub, so what are we subtracting? So EAX, EBX. So we are subtracting EBX from EAX. So this is initially we are saying that just EAX minus EBX, so which is an equivalent of 50 minus 40, like that. So if we run this program and see how, what it outputs, so this is a comment, so let me put a semicolon. So remember, comments are ignored by the assembler and the compiler. So just if you want the compiler to ignore something, you just use the semicolon to indicate this is a comment. So with that, after loading our raw values inside our register EAX and EBX, we can just use the sub command followed by EAX. So we haven't finished. So EAX from EBX, like that. So now the mathematics will be like that. So it will take the value EAX, which is 50, then minus EBX, which is 40. So remember, this is the process of subtracting, or this is how you subtract two numbers using assembly. So I can go ahead and save it, then just compile it afresh. So you can compile it, then when we run the debugger, you can see now the values now without using the external variables. We can use ASM, so followed by breakpoint, which is at the start, then run. We step into step I, then we can do the info registers EAX, which stores our result 10. So that's subtraction. I think I've explained it very well, but if you have any question, you can always ask in the comment section and I will be happy to help you. So don't forget, this is the main takeaway. So after moving the values EAX and EBX, subtraction, use the sub keyword, then you put the destination and the source. So it will minus the destination or the source from the destination, or it will just take EAX minus EBX and it will give you the final value, and the final value will be stored inside the destination register, which is EAX. So with that, I think that's a basic overview about subtraction. So but in our following videos we'll be experimenting into some maybe complex programs, maybe taking input from the user, or maybe subtracting more than two values. So we'll see that process or that problem as we move on our video series. So if this video has been helpful to you, just leave a like, comment and subscribe, and just turn on the notification bell in order that when I upload a new video, you'll be notified. So this was all for today, and see you on the next video.